Okay, just, there we go, so it's on the thing, so I know what I'm talking about. 16. I have seen so many silver bullets come and go. There was a famous program that was written back in the days of personal computers called The Last One, meaning it was the last program you'd ever need because it was going to write all your programs for you. My gosh, this was written in BASIC and running on a PC. And they thought this was going to be the end-all and be-all of program generators. It came and went very quickly. Object-oriented development. When it hit the big time, late 80s, early 90s, it's kind of like, you know, you code 4 to 10 times faster, and you don't have to have quality assurance and so on. I did real-world production coding in Objective-C from 1990 to 1995 and wrote the book Pitfalls of Object-Oriented Development. The first several chapters of which are basically saying, this is why it doesn't solve all your problems. And in fact, later in the semester, Webster number 7 readings, I've been working on basically just updating and revising it to Pitfalls of Modern Software Engineering. Because those first 3 chapters, they basically apply to any, what I call the technology or methodology, a TOM. And people say, well, this will solve all your problems. You know, React will solve all your problems. Agile will solve all your problems. Whatever the methodology, the code, the technology du jour is going to solve all your problems. It doesn't. And the reason, Brooks talks about essential complexity and accidental complexity. Accidental complexity are the things that are just sort of issues that crop up out of your control. Back to the example with Squid. You think Squid can do this, turns out it can't do it. Lost 4 months, 5 months, whatever, using it. But that wasn't an essentially difficult problem. That was simply a decision made without complete knowledge as to, you know, what Squid could or couldn't do. Likewise, some of the problems about, you know, stuff that was working. Well, actually, that's almost a different one. Essential complexity is that there are essential, well, he says, 4 inescapable essential difficulties in software development. First is complexity. Complexity grows non-linearly. It grows faster than program size. A program that is twice as long is not twice as complex. It is some fractional power of 2 more complex. It's, you know, 2.5, 3, 4, depending on the nature. And the complexity increases both from a technical point of view and a managerial point of view. You start to reach the limit. How many of you have had the experience of coding and you're there, and preferably, and we'll talk about interruptions in your environment when we get to peopleware, but you're in a quiet, isolated environment and you spend an hour building your solution in your head and holding in your mind what all the code is supposed to do. And the phone rings. And it goes, and you know, it's like, oh, you answer the phone, and then, you know, you get, it doesn't take you necessarily an hour to get back there, but it takes you a while. I had an experience while working on Sundog, which I did 90% of the coding for. I mean, I knew the memory map down to the byte level. It was, you know, running on a 64K Apple II. I had done, it was using Apple Pascal, but I'd written a graphics library from scratch. I'd written, you know, I wrote a disassembler. I disassembled the P code interpreter and could disassemble P code itself. So I could disassemble both the pseudocode, it's like Java bytecode, and the 6502 code. So we could get in there and hook and do things for real-time effect and so on. So I'm in the middle of coding something, and I've been through that process. I've spent a good hour with all the structure of code that's loaded and code that's not loaded. I'm doing this and I'm doing this. And I'm in the middle of programming, and Wayne Holder, my friend, the company owner, the guy who hired me, comes in to talk to me about something. He said, hey Bruce, you know, I've got a question for you. And I turned and didn't say anything. I just sort of glared at him like, go away. Because I knew if I opened my mouth and started talking, I was going to lose everything I had. And he was sort of puzzled, And he said, "Is there something wrong?" And I didn't say anything. And finally, like, "Well, okay." And turned and walked away. And I managed to hold all that in my head and went back and coding. And an hour or two later, when I was all done, I said, "Wayne, I apologize if this was happening." And he was like, "Oh, okay, I understand what you're doing." He says, "I'm sorry I came in. I didn't mean to interrupt you at that moment." Software is the most complex thing that humans do. Software programs can have numbers of individual states that put the universe to shame. You're talking, you can have a decent sized software program that can have quadrillions, quintillions of individual different states, and yet we have to somehow bound this and say, yes, and it's going to work properly in all those quintillions of states. And there are techniques to sort of bound it and so on, but that is the problem. Again, back to the shuttle launch. I mean, this software had been worked on for years, tested and tested, and when they went to the first live launch, there was this 40 millisecond discrepancy between the two computers. It took them 2 days to find it. Huh?
I think it's pretty fast to find some bugs.
It was. He had a $1,500 bonus, which was probably about a month's pay at that time.
What?
Well, this is 1970,
Okay.
1981.
That explains a lot.
Yeah. I was making, let's see, I was at LPI, I was making $20K a year, I think,
Okay.
at that point.
Yeah, like inflation is a thing.
Yeah. And actually, inflation was a thing. This is the Carter years. Inflation was running at 15 to 20%. I was losing ground. The only way I was keeping my salary even with inflation was job hopping.
Okay.
I had 4 jobs in my first 4 years out of college. Conformity. Okay. Back to Sundog. Doing this game, I've got the Apple Pascal, P code, which I've just assembled the whole thing. I know how everything works. I know what's going on. I know how everything gets loaded and so on. Take your environment today. You're writing an app to run on a mobile device or to run on Windows or Linux or whatever. Stop and think about all of the external systems you depend upon, whose behavior you do not control.
I would rather not think about that. Thank you very much.
Well, it provides an upper bound to the reliability and quality of your system. You aren't in charge of everything. In fact, you're in charge of less and less. And you're open and exposed to things that you don't necessarily know you're open and exposed to. Changeability. What does everyone want to do? Well, let's add more features. Want to fix the bugs, want to add more features, have to make it competitive, need to make it competitive. And invisibility. We've already mentioned this. You watch a building under construction, there's a big courthouse downtown Provo, there's a hospital over here, there's stuff here on campus. And you can walk by and eyeball it and say, hey, I see the progress they've made. They've got, it's a hole in the ground, and then they have a foundation, and then you've got a framework, and then you've got walls and floors going up, and then they've got a cupboard, and then windows are starting to appear. Anyone can at a glance, now there doesn't mean there aren't architectural problems with it, or delays being caused by something, but you still have a way of eyeballing, okay? How do you eyeball a 500,000 line program? And say, yes, I know how far done it is. This is why software is so hard. It's very ethereal. It's very hard to figure out just how far done it is. Now, and by the way, I'm assuming all this, I'm not going to cover everything he says. I'm assuming you're actually reading this stuff. But things that do help. Buy versus build. I've talked about this. You buy the stuff you need simply to play the game. Don't, unless you will gain a competitive advantage by building your own graphics and physics engine, don't. Buy one, license one. Use one that's free. The competitive part is, the game design. The competitive part is the application design, the management of information you have. So buy a solution that someone else maintains. Now the problem here, the problem with buying is a classic problem, which is if you buy it and then have to modify it customize it for yourself, you can lose the updates and fixes that come along later. Or if you, this is a common problem. I deal a moderate amount with SAP installations, Enterprise Resource Planning Code. Actually, there's a number of different ERP projects. And you buy, let's call it version 6.3. You do all this configuration and customization, and then they come out with version 6.4. There's not always an easy upgrade path there. And so you have this trade-off of, oh, we're just going to stay with 6.3 and with our customizations, or we're going to go through the pain and time and expense of trying to upgrade to 6.4 and then recreate or put back in our customizations. Requirements refinement and rapid prototyping. This is, again, a lot of the impetus behind extreme programming and agile. The idea of let's prototype quickly, let's get stuff out there, let's get the customer feedback as soon as possible. You don't want to spend a year working on a project, show it to the customer, and the customer say, no, it's really not what I want at all. Incremental development, again, same thing. He's invading against the classic waterfall approach. Design a little, code a little, test a little, and try and get that done. Now, there are problems with that I'll talk about, yeah.
So, the article talked about solutions to the accidental problems, high-level languages, and having machines that had more than 16K of memory and that kind of stuff. What's the difference between those and these solutions?
Well, these solutions, these are solutions that still apply. Buy versus build, requirements refinement, interconnected development, great designers. The highest compliment that I've found that anyone ever gives to code or design or architecture is elegant, which is shorthand for being, I wish I had done that. It's like, what a great solution. It's not something that's obscure or hard to follow or hard to fix. It's something that's clean and clear, and the proper design can make a difference. Now, having talked with the delays and problems with pages, I will brag on my architecture there. It was done, most of the architecture work was done in 90 and 91. I spent a lot of time on it, a lot of refining. And not only did it work all through there, but in 1994, when HTML and the web appeared, it took us only 4 months to turn this 400,000 line design-oriented desktop publishing system into a WYSIWYG drag-and-drop web page editor. Everything just fell in because of the architecture, because we had gone, because of the choices we had made with the architecture, with the document structure and everything else. Doing web pages just almost fell out of it. It wasn't a kludge. It was a very, very wonderful type fit. Sadly, it only worked on Next Step, and like I said, we spent first half of '95 trying to get venture capitalists to allow us to port it over to Windows to get the funding, because we pretty much saturated the Next Step market, and they all said, no, we don't know what this web thing is. So we closed our doors. I still have the bookshelves out of my office. Anyone have observations or questions on these items? Yeah.
So in your experience in the last 40 years, has there been anything that has come closest to being the silver bullet?
No. No, it's...
That was
Part-
fast.
Okay, who was on top of the list? What revolution,
Yeah,
what
what was the
technology,
closest
paradigm?
The bronze
The
bullet.
question is, what's closest to a silver bullet? I haven't seen the silver bullet. There has been incremental improvements in tools and libraries, but they bring their own costs. I thought, despite having written a book called Pitfalls of Object-Oriented Development, I thought Object-Oriented Development was a major development, and that sort of pushed forward, but the problem is it was accompanied with so much hype that stretched it beyond what it was. You had a development of going in the 60s and into the early 70s. You had the structured development movement. Object technology really pretty much came along late 80s, early 90s, and had a lot of hype, and everything was object. Oh man, you can't believe how much everything was objects. And then in the late 90s, you had everything's on internet time and internet coding and eyeballs and everything else. And that having done a venture-funded startup, I was watching these .com companies that were burning through $10 million a month. We made $7 million last 3.5 years. We were burning through $10 million a month with no visible plan. And I ran around telling my friends, this is going to be so ugly. This is going to be so ugly. I still have a friend, Steve Jasic, who I said that to, and he pulled all his money out of any tech stocks. And of course, NASDAQ peaked in March of 2000 and crashed badly over the next year and a half. And he still, every time we see each other a few years, he says, thank you. He says, I owe my retirement to you. But it was so obvious it was going to be, and I knew it was going to be ugly for a couple of reasons, because I was also involved, got sucked into Y2K, and you had corporations spend vast monies basically replacing all their existing systems. And so at the same time the dot-com bubble popped, you had all these corporations which had just blown through what would normally be their IT budget for the next 10 years. Basically, U.S. corporations spent about $100 billion on IT, on Y2K remediation. Because it was a chance to finally kill off all the systems, hardware and software, that they'd been unable to kill off before. That's a whole other discussion. So the short answer is, I see lots of incremental improvements. There is constant upgrading of the craft. Software tools get continually better. But you know what? The complexity demands continue to increase. You know, Sundog ran in 64 kilobytes of memory. That was the operating system, the graphics library, the graphics screen itself, and the entire program. We swapped code in and off of a floppy drive. Fit on two sides of a 140K floppy, so it was 280K total. I mean, that's about as much memory as a nice icon takes up on your screen nowadays. You know, I download stuff off of Steam now. It's like, oh yeah, downloading 2.3 gigabytes.
Those are rookie numbers.
Yeah. So it's you know, it's the level of complexity has grown, and there really aren't silver bullets because the bar keeps getting raised. Other questions? Yes.
So the book said that like the difference between like an incremental improvement, like the silver bullet, is like one does like less
5 to 10%, I think he said.
5 to 10. The other one's like an order of magnitude
Yeah.
improvement. Okay.
And it may be hard to believe, but there have been a lot of silver bullets that people claim would be an order of magnitude.
Well, what was the last one that was an actual silver bullet?
Well, I can't think of anything where you got an order of magnitude improvement. That's the whole problem. It's been claimed for a lot of things, and it's never panned out.
It's like the invention of the computer was the last silver bullet.
Well,
I don't even know if that was a silver
I'm not even
bullet.
sure about that. There were a lot. It took a while for actual electronic computers to catch up with human calculators who were
Right.
basically generating the same tables. Computers were originally used back in World War II to calculate ballistics tables and so on. You know, you got a shell of this size, you want to shoot it this far, you want it to land here. Here's the angle you have it at. Yeah.
I think one of the big ones I can think of is, I think it was like the 1890 census or so.
Hollerith card, punch card.
Yeah,
That actually probably was an order of magnitude.
because it took, what, 11, 12 years for the last census, which is a problem.
Yeah.
Uh,
Now the Hollerith cards and the Hollerith cards are what became computer punch cards. I mean, I programmed using punch cards, but Hollerith cards were they would punch holes. They had rows and columns, and they could punch stuff for the census information, and then very quickly tabulate it using mechanical equipment.
Because I think that reduced it to what, like a year and a half?
I don't know. I would have to actually study that, but yes, that was actually a major breakthrough.
Is there like a time frame for the silver bullet to become a thing in order to increase some like productivity by an order of magnitude?
Well, I don't know that object technology. I mean, object technology really hit its heyday 30 years ago, and I don't think it's produced an order of magnitude difference in programming time.
I
30
was
years.
mostly thinking of like the buy versus build when using existing code bases. Because if you want to make a web startup nowadays, you don't say, okay, let's make a JavaScript framework and let's
Go out-
find some let's
Get a
go
stack
find
and
some
start
backup
from there,
servers.
yeah.
It's like, no, we're going to go buy this and buy this and buy this, and then we buy, oh, let's do a tiny little thing on top of it.
Yeah.
So,
And well, that's this whole point. The extent that you can buy or if it's open source, simply use, is what cuts down your time. I don't know if it's a silver bullet per se, but it is a shortcut. It's probably an order of magnitude faster than building your own internet stack.
Yeah, probably.
Anyways, it's just like you probably wouldn't want to build your own operating system at this point. For much the same reason. Okay. Now, he did this in '86. There were people who protested and said, "Oh no, this is going to have silver bullet." Brad Koch, who actually invented Objective-C, thought that we were going to have software with interchangeable components. And this was a move for the big reuse push in the '90s, which pretty much went nowhere. When I was at Fannie Mae, one of the things I did is they were in moving to object technology, which is why I got brought in the first place. They wanted to look at code reuse. Fannie Mae, for those of you who don't know, it's it was publicly traded until a big scandal and the stock got delisted. But it was set up by the government primarily to buy mortgages from banks. So if a bank held a mortgage on a house, say $50,000 mortgage, Fannie Mae would come and buy the mortgage from them and pay them whatever the balance was due on the mortgage, and the bank now had more money to offer a new mortgage. Fannie Mae would then manage the mortgages. Now, to get money to buy mortgages, Fannie Mae would bundle these into mortgage-backed securities and put them out on the securities market. And it'd say, okay, we've got these, this package of 1,000 mortgages, and here's the rate on it, and here's the rate of return. Someone would say, yeah, I want a piece of that because I want some of the interest off it, and they'd get more cash and they could go buy stuff. Part of the subprime crash was caused by the fact that Fannie Mae, in order to make housing affordable, was pushing loans and buying loans that were not properly backed, and still selling this on the mortgage-backed securities market, and then people started defaulting on loans big time, and the whole house of cards came crashing down. It was discovered Fannie Mae had been fudging their finances. All that said,
See the movie Big Short.
yeah, it was the there is the stick figure PowerPoint display, quite obscene in its language, that basically is here's the subprime crisis explained. Go track it down and watch it sometime, because it nails it in about 20 screens. I watched all this happening, and it was pretty ugly. Anyway, I'm not sure how I got off on that. Oh, Fannie Mae, reuse. Reuse was a big thing they were pushing. And since they do loans, they thought, we're going to have a universal loan project. We've got all these objects. We have all these programs that manage loans. So let's have a single loan object, and all the programs will do that. And they had a reuse group, and I was mentoring that group, and they worked for about a year. And the reuse object they came up was like this giant bloated thing. It had a couple hundred fields. It had several hundred methods. Very bloated, heavyweight object because it was what everyone wanted. The truth is that a loan object looked quite different to different parts of the company. And to try and make a universal one didn't work. This is pretty much what happened with most reuse efforts. We'll talk about reuse later. Vanilla Framework. Dave Harrell apparently came up with something called Vanilla Framework, which he thought was going to be a silver bullet. You ever heard of it? I actually hadn't. Object-oriented development. It was, people are saying 10 times, 4 to 10, 5 to 10 times faster coding. No, it doesn't work that way. Trust me. And after 30 years later, I agree with Brooks. It's still there. There are no silver bullets. And part of what your managers are going to try and look for is they're going to look for silver bullets. And part of what you're going to have to be willing to push back and say, no, it's still going to take time. There's no magic pixie dust to make this all just work. It's a lot of going back to armor. It's a lot of exploration, a lot of trial and error. Chapter 18 is really just a summary of his original book. This is a great cheat sheet for the open book midterm. Because I'll provide citations. Go to chapter 18 and flip through and say, oh, here we go. It's in this chapter, and then flip to that chapter. Seriously. This is probably one of the best cheat sheets you can have for the entire thing. And by the way, yeah, you're free to make up your own cheat sheets. I encourage it. Take notes, you know, crystallize this stuff. My point with the midterm is to know that you know this stuff and know where to find it. As I said, my midterm last semester, there was 1 B+ and everyone else got an A.
Was it open book? What was
Yeah,
it?
it's open book, open note, open device. No, you don't have this memorized.
Open internet?
Yes, open internet.
Oh, okay.
It's open everything. Now, the problem I had, and I discovered last semester, when I taught this winter last year, it was over in the Tanner building. They had those tables in front.
Yeah, no outlets.
And so, yeah, I just had people there at the, just, you know, open up your, plug in your laptops, do this, and it's all electronic. The test is going to be on Learning Suite. Last semester, we only had a third of this many people. We had like 21 people. And about halfway through the test, it's like, uh-oh, people had laptops that were starting to run down. So what I'll probably set up is not something here in class, is I'll try to find, and I know Chuck did this, I think there is a place where you can go and log on the computers, and then you'll have a timed block for the test. And just do it sometime on that day, so we just won't have class on that day.
There's one of those in the basement of the JFSB.
Yeah, I think that's,
Could we also alternatively just do it on
Stay
the
at home.
computer?
yeah, you can probably just stay at home. You know, guys, honor code, I trust you on this. But you'll just need, I'll set up something for if you're on campus, you want to come to it. You know, and I built up enough of a question base, I may mix it up, so you may get a random assortment of like 5 questions. But anyway, so great cheat sheet. After 20 years, this is still a book I use today. I mean, the reason I'm using it here in class, the reason I used it, this was part of my expert report and my testimony in New York last summer, and you know, the opposing attorney said, well, you know, isn't this an old book? Isn't true technology changes fast? I said, this book nails all the issues. There's a reason I use it as a textbook. And as I said, it's you know, how many of you had heard of the Mythical Man-Month before coming to class? Okay, fair number of you. You'll find when you go out and work and say, have you ever heard of the Mythical Man-Month? People say, oh yeah, I've heard of that. Say, can you quote anything from it? And usually it's going to be one of 2 things.
Out of context.
Well, no, it's relative. They say, well, you can't make a baby in 1 month with 9 women, which is an analogy he makes, which actually Jerry Weinberg made first in psychology and computer programming. Or they'll say adding people to a late project makes it later. And if you said, have you read the book? They'll say no. And they say, are you trying to find it? So no, we're late. We're adding people to the project. So that's why you have the universally known, often quoted, occasionally read, and rarely heeded. And I see this over and over and over again. I mean, I have personally reviewed in many different contexts and at many different levels about 150 failed IT projects. And I can almost always point to core issues out of this book as to why they failed. He thinks his biggest arguments are the need for conceptual unity and a chief architect, and that's a major quality issue for program. At Fannie Mae, I was called back in. I think I may have mentioned this to you. Forgive me if I repeat stories. Well, let me generalize it. Over the years when I've been called in to review troubled projects, corporations, the first question, or one of the first questions I ask is, who's the chief architect? And often the answer is, no one. That tells me probably about 50% of what I need to know. If there is no one overseeing the conceptual unity of the project and how the pieces fit together, that explains it. When my first consulting job was at AirInc. They were doing the network management subsystem for the Motorola Iridium satellite phone project. And that was the question I asked. And I literally got 5 different answers. 4 different people, and about a third of the people said no one. And I said, can you show me the architecture documents? And there were 4 subsystem design documents. There was no overall architecture document. When I tried to match up the 4 subsystems, they didn't fit. They showed unmatching interfaces to communicate among them. And one of the first things I had to do was actually come up with an architecture for the overall subsystem, then modify the design for the subsystem so they actually Brooks, back in '95, thought that voice interface was eventually going to replace on computers, not mobile devices, the Windows icon, mouse, pointer, what he calls the WIMP interface. We're still using 20 years, 20 years after that, we're still using that interface. We don't talk that much short computers. Yeah.
Would you consider changing your opinion as far as like Alexa and Siri and other?
Oh, I have Alexa, and I would say no. I actually very much like Alexa, but considering the fact that as a friend of mine and a fellow blogger put, she got an Echo. And she was doing, my main use for Alexa is the shopping list, and she said, Alexa, add fruit to the shopping list. And when she got to the store, looked at the shopping list and said, poop. And I've nothing that funny, but I've had those moments like, what's a camel barge? What did I say that Alexa thought I was asking to put a camel barge on the shopping list? I'm a great fan of voice stuff. I wish my Apple TV had voice interface.
It kind of does.
Yeah, but I wish it had a voice initiated. I walk downstairs, I've got this home stereo and TV with the Apple TV hooked up, and I've got my little Alexa sitting in the kitchen. Guess which one I use to stream music 90% of the time? So I have to say is, Alexa, play my morning's playlist.
Go home, dude.
And well, I'm happy. I'm happy with Alexa at this point. Anyway, but the point is I see voice as important. But if I'm word processing on a computer, no, I want a mouse and Windows and so on. Dictation might get there. I'm not sure. It strikes me as tedious to try and navigate around a file system using voice. Pointers are much faster. We have other stuff. He pretty much stands by it. And I'm assuming you guys, people are everything. We're going to talk about that. I want to hurry here because we're actually going long here. This is probably the most amount of talking you'll hear from me all semester. So let that comfort you as we finish this up. Biggest surprise he had was the millions of computers. We're not talking about at least a couple billion PCs out there. And then you throw in mobile devices, and you've got a few billion more.
Don't forget the smart light bulbs.
And yes, the smart light bulbs. I found it interesting, he mentioned there was this whole thing with 4th-generation programming languages back in the 90s. HyperCard, PowerBuilder.
Smalltalk.
No, Smalltalk was a true OO system. But there were a number of 4th-generation, supposedly regular, ordinary people would be able to code using these systems. They're all mostly gone now. This, again, is something I've seen is just... The IT industry is volatile, but that said, you guys have a lot of job security. The problem you've got is that getting a company to hire you because you actually are good at this versus hiring someone because they're cheaper or possibly in a few years younger or they clean up an interview well, whether or not they're actually competent in what they're doing. Okay. Yeah.
So, like, aside from like the voice interface stuff, did Brooks miss anything else big?
Well, I assume you read the book. He talked about 4GLs. He talked about the amount of shrink wrap software, which is actually the amount. What do you mean by software? About anything. And of course, with mobile devices, you have a zillion apps out there. And once again, with the issue of how do you choose among them and what do you know is actually worthwhile. And then you've got that leads to well, free, but with in-app purchases, and it's kind of like, okay, you know, which one do I pick, and do I want to pay money for this? You know, how many of you have bought an app and done some in-app purchases and said, actually, this really sucks? I have done that, yes.
Yeah.
Yeah, question?
Do you think quantum computing would be a silver bullet?
It,
Because it can change how you code entirely.
well, change how you code, I'm not sure, it can change the processing speed. I mean, the true silver bullet has been the increase in speed of processors, in the amount of memory. I mean, it's staggering. Like I said, 30 years, it's only 30 years? 30 years ago during Sundog, I had to fight to get Wayne to let me go from a 48K Apple II to a 64K Apple II as a target system. You know, my laptop here has 16 gigabytes of RAM, and that's modest nowadays. My son Aaron runs the lab for the information technology department over in the Crabtree building, meaning the department that trains network administrators and system administrators and so on. And he's got a system there with 1.5 terabytes of RAM on it. He showed it to me. He was like, yeah, this is when I have terabytes of RAM here. I mean, I had for many years a personal goal to have a home system that had 1 terabyte of storage on it.
Oh.
And I achieved that, I want to say about 10 years ago. I mean, that's like trivial these days.
Yeah.
So now I'm up to a petabyte. I want to live long enough to have a home system with 1 petabyte of storage. and a terabyte of RAM.
You can just buy it on the cloud.
Yeah, it's
have,
just-
have it at home.
Yeah, but I want to know. I want it right, it's sitting right there. I want a terabyte of RAM and a petabyte of storage.
You just gotta talk to Amazon about like making like their next data
On my
center in your
system. So
backyard.
that's give me a reason to live for the next 20 years. Okay, we still have to talk about organization chart, and I'll try to make that relatively quick. By midnight Saturday, your org chart and your roles, responsibilities documents should be on your wikis. Make sure I can see these because I'm going to look at them. Trey's going to look at them, and we're going to present all of them in class next week. For next week, your reading is DeMarco and Lister, chapters 1 through 6. Peopleware is a very fast read. The chapters are very short. The chapters are typically about 4 to 5 pages long. It's very breezy. I mean, chapters, let me give you an example here. And there's a lot of filler and white space, but that said, chapters 1 through 6 represent about 31 pages, including blank pages and chapter headings and chapter titles and so on. It's a very fast read. And Webster number 2, set of readings, I forget which ones those are offhand. And if you get your org chart done, mark off billable hours. You get full credit if the org chart and rules responsibility document is done. Let me bring this up. Now, as I said, I'm going to generate templates, but frankly with org charts, it's going to be whoever does the actual drawing, whatever app you feel comfortable with, as long as you end up in a form that Ty and I can actually read it. This really is the most talking you'll ever get out of a single classroom. Why have roles and titles at all?
So people know what they're doing.
Well, yes, actually, hang on a second, let me